And now Sandra will present evaluating seasons of prescribed burnings in coastal prairie and interior coastal plains rangelands of southern Texas.
Okay.
Sí, ves.
Good morning. Thanks for being here. I'm used to wandering around when I talk, so we're about to find out if I can sit still and talk at the same time. I want to talk to you today about 4 different studies that we've done with our students on season of burning, comparing season of burning on the vegetative effects in southern Texas. Just as a little background, the sites all 4 share some similarities in climate and fire history. It's a humid subtropical climate. The precipitation, there's a little less than 100 centimeters per year, but it falls mostly, about half of it in May, June, and another quarter in August, September. The soils are usually sandy. Fires are well documented by early explorers. The early records depict the area as pasture land with dense brush mottes, and natural fires we think probably, were started by lightning in the summer, but Native Americans generally may have extended the burning season. So we get asked the question a lot, when should I burn? Should I burn in the summer? Should I burn in the winter? When should I do this? What's the best time? And of course, it depends on what are your objectives. So from each of these studies that we did, I only have time to share with you just 1 or 2 statistics from each one. So the first one is a study that we did on the coastal barrier island, Matagorda Island, and it's dominated by marsh cordgrass and Gulf dune paspalum. It's very important wintering habitat for birds. Hundreds of different species come through in the winter, and it's the only place that the whooping crane, the endangered whooping crane, winters. So it's really important that they get that right and manage it properly for the wildlife. They wanted to know, winter or summer, but also backfire or headfire. We used 12 main plots, about 120 hectares each, 4 control plots for winter burn, for summer burn over 2 different years. And in those burn plots, half of them were burned with headfire, half of them were burned with backfire. There wasn't much lasting difference in grass yield. It was same as pre-burn by 2 years. For forage production, it was higher than the pre-burn levels on both control and burn 1 year after burning, and there were no differences between burn and control because it's a precipitation effect. The precipitation, when it's a good rainy year, can overshadow your fire effect, and we think that's what happened on this fire. But we did see some differences in species frequency. The Gulf dune paspalum, which is one of the most common species, was decreased and remained low still after 2 years after burning, which is probably good, gives some room for other species to come in. Coastal mistflower is an important nectar flower for pollinators like butterflies and bees. It was decreased in the first year, but there were no differences by the second year. Beach ground cherry is an important food source for the birds. 2 years post-burning, it was higher in the summer burn plots, but lower in the winter burn plots. All the legumes in the Fabaceae species followed the same general trend. They were higher in summer burning than winter and control plots, both 1 and 2 years post-burn, and those plants are also really important for the birds. That's what they'll be foraging on through the winter. We found no differences whatsoever between headfire and backfire. That's kind of good news. You can choose whatever is going to be most convenient for you in a particular burn unit, given particular weather conditions. And so it looks like the summer burning may have the advantage there when managing for those wildlife. The second study also took place on the coast, but it's not in an island. It is right on the Gulf Coast. It's dominated by Gulf cordgrass, which gets really old, coarse, decadent, becomes unusable when it's mature. This is a private ranch. It's got about 28,000 acres, and there's no interior fencing. They do run cattle, and they manage for wildlife. And the cows were just left in there, so it's a patch burning project, basically. We have 10 plots. 2 are control plots, 4 are winter burn plots, 4 are summer burn plots, and we've only finished the first year, so 2 winter have been burned and 2 summer have been burned. The winter year 2 will hopefully be burned next week as soon as I return and we get a burn window. One of the things that we look at a lot is here lately is mortality of these perennial grass plants, because we're told, at least in North America, we've been told for years that fire doesn't kill perennial grasses, but we've seen otherwise. So we've just been marking plants to look at afterwards, or marking quadrats, so that we don't have any spatial variability. We're coming back to the same place. The green arrow there on the x-axis marks a winter burn, the February burn, and the red arrow marks the summer burn. So you can see immediately right after our winter burn, we had increased mortality in the winter burn plots, but then after the summer burn plots, the summer burn mortality jumped right up. So we are killing some cordgrass, and that's the major forage, and summer burning did kill more than winter burning. One of the things that we're looking at in this study, because this ranch is so interested in its livestock and the nutritional changes in the cordgrass, one of the things we're looking at is neutral detergent fiber. Of course, fiber, you want fiber to remain low, but the neutral detergent fiber is the most highly digestible of the fiber. We used a regression, and we found that a stepwise regression with 2 breaks there was the best fit. It's fairly level at the top, and then we burn right around right there at day 0 on the x-axis, and then you see a sharp drop in the neutral detergent fiber as soon as the new growth is coming in. It bottoms out about 30 days, and then it comes right back up. And so by 90 days, your advantage really from burning is gone. This is just the winter burn. We aren't finished analyzing in the lab the summer burn samples, so it'll be interesting to see how that compares. Our third site is an inland site, and it's an inland prairie that's been invaded by a non-native grass. It's Clayburgh bluestem. That's an old world bluestem, so it doesn't belong there at all. It was brought over for forage, and it makes good forage until it gets old and decadent. And then it's really good for nothing, but it's a great competitor, so it makes these great monocultures. Oops, wrong button. We have 2 sites, and on these sites we burn small exclosures that give us an opportunity to replicate quite a bit, and also an opportunity to really intensively manage what's going on inside the plot with permanently marked plants and quadrats and that sort of thing. Of course, we want to know what's the best season for trying to control that Clayburgh bluestem without harming what few natives are there. Now, this is kind of a crazy graph, so let me orient you to it. So along the x-axis, along the bottom, the dates are sampling dates. Red arrows are summer burns, green arrows are winter burns. And those we're looking at mortality again of the Clayburgh bluestem only, because that's the one we're interested in decreasing. So the number of dead plants is on the y-axis on the left. The black arrow, or the black line that stays fairly level, that's the control, that's non-burned control. And you can see in the red, the summer burn jumps right up right away, and there's a difference between summer burning and winter burning the whole way through, and summer burning and control the whole way through. Winter burning is in green, and there's just one time where there's a little bit of a difference between winter burning and control. Some of these plots are being burned every year, and that's what the solid red or the solid green is, and some of them are being burned, have only been burned once. Over on the right, the y-axis on the right is rainfall, and there are dotted blue bars that are corresponding with that axis. And we show that right before the sampling period so that you can, if you're wondering, well, is rainfall more important or is fire or fire plus rainfall, you can see when we got a lot of rainfall and when we just got a moderate amount. We have the same thing now with recruits because, if you're counting how many you're killing, you also want to know, well, how many are you causing to come in and are you offsetting that? So we're counting true recruits. Same setup with the arrows and everything, and the axes are the same. You can see again that our summer burns are also recruiting more of the invasive clayburg bluestem, even though they're killing more. And winter burns now do show some differences between control plots too. So even the winter burning is recruiting some more plants. Our fourth site is another inland site, and it's also one that's being invaded. This time, though, the invader is a native species. It's only been behaving, it's only been behaving invasively for the past 15 years or so. It's called tanglehead, and it has a lot of awns with the seed. They get all tangled up together, hence the name. Nothing wants to eat it, nothing wants to live in it when it matures like that. We're working on a private ranch also. We have exclosures inside the burn units, and we just want to see what's the best season for controlling this tanglehead. I'll show you a mortality graph. Again, we've got a fall burn on the top and the spring burn on the bottom. Now, the fall burn, you can see mortality of the tanglehead. This is just tanglehead mortality. Mortality jumped up to about 70% right away, but it came down, and these are individually marked plants. So in other words, some plants that we thought were dead initially were not dead. They came back to life. And so after several months, there was about 45% mortality. As opposed to the March burn did have a lot of mortality, of 70% maybe, and it stays fairly high after a while. They are truly dead. They didn't come back to life. If we compare over time the fall, this is recruitment now, the fall recruitment to the spring recruitment. We don't have any stat here. We're just showing you the error bars. You can see the fall recruitment stays high, and if you'll notice, these are two different scales. The fall recruitment goes up to 80, but the spring over on the right only goes to 40. So the fall recruitment, we recruited maybe 60 seedlings per square foot after fall burning, and it doesn't drop off really quickly like the spring burning does. So looks like fall burning is the worst for recruiting new individual tanglehead. So as conclusions for the barrier island, the summer burning every 2 to 5 years might be most advantageous since they are managing for wildlife. In the coastal cordgrass, the summer burning kills more cordgrass, but the cordgrass is the best forage in that area for livestock. So it depends on whether you're running livestock or wildlife, where you might choose winter burning or summer burning. The clayburg bluestem, it looks like the summer burning kills more clayburg bluestem, but winter burning recruits fewer. So if you have a stand that's been completely invaded by the clayburg bluestem, you might want to use the summer burning to try to kill some. If you have a stand that's just been partly invaded by the clayburg bluestem, maybe you want to choose the winter because you would recruit fewer. And our season effects are variable. They vary across vegetative types and with varying precipitation. Thank you so much.
Time is over, but perhaps for a very short question. Is anybody? Okay.
Hi, thank you. I'm Christina Santin from Swansea University in the UK. I was wondering the third experience that you were saying, what about native species? Because it's something that you were also considering in the third, I don't remember the name.
Third site?
Yeah.
Yes. What are the native species?
Yeah, because you said you wanted to increase the mortality of the invasive species and minimize the mortality of the native.
Actually, yeah, the natives were not harmed. We did find that the natives were not harmed by summer burning like the clay-red bluestem was. So that's a good thing, a really good thing. And there's just really one native, it's Texas 3 on. So that's it.
Thank you.
Yeah.
Thank you, Sandra.